So how many questions do you have for today?
Can you hear me?
Yes, sir.
So let's discuss the problem. Okay.
So how many questions do we have for today?
5, 6 questions are there in total. So given a list of integers sorted in ascending order, write a recursive procedure that returns the list sorted in descending order. So the list is in ascending order and we have to write it in descending order using recursive procedure. So here they have given a set of codes also. Procedure descending L. So L is the ascending list. We are taking that list as a parameter in this procedure. After that, we are checking if the length of that list is less than or equal to 1 or not. So if it's less than or equal to 1, then we'll return L. So we'll return that list only. If the length of that list is less than or equal to 1, we'll return that list only. And if it is not less than or equal to 1, then we'll not come into this if block. We'll not enter into this if block. There is one more line that is field code here. So that's a blank and you need to choose the options. So here there are A, B, C, D. 4 options are there. Let's check which one is correct. They are telling option A and option C are correct. Okay, now check. Yes, well done. No wrong answers have been posted in chat. So the thing is how option A and option C are correct. So if you go through this, return last of L plus plus descending initial of M. Okay. So what's happening is Yeah. So return last of L. Here they are writing this line, return last of L plus plus this descending initial of M. So when we write this line, return last of L plus plus descending initial of L, so we are calling this recursive function again. Okay. So this recursive function is being called again with the new L, that is initial of L. So L has this value. Sorry, L value is not true. So suppose L has three elements. Okay. So initial of L, it will give us the first two elements of L, right? So the length of L this time will reduce by one because the last element has been dropped. Got it? So if I write this line, so gradually it will happen what? Again, it will recursive itself. Okay. Again, it will return the initial of the current L. So from the three elements in L initially had three elements. The third element dropped. Two elements are there, and we send that those two elements again into this recursive function. Okay. After that, again, what will happen? We will send the first element because the second element will also drop. So the single element will be sent into this recursive function. At that time, what will happen? It will see that the length is less than or equal to 1. This condition will match. At this point, it will return L. So this first element will be returned. Then the previous return values are also pending. So at that time, this thing will be returned. Okay. Last of L,
So can you please explain this using an example?
I think they have to. 1, 2, 3, 4, 5, 4, 5, 4, 3, 2, 1. This is the output. Okay. So it's like turning it, flipping it. Now what is happening? Let's check. Yes. This is initial of L, 1, 2, 3, 4. This is last of L, 5. Okay. After this, return last of L plus plus descending initial of L. So here what we are doing, first we are sending this 1, 2, 3, 4 to this initial, to this recursive procedure. Okay, this part. We are sending here this 1, 2, 3, 4. So at first, in the first iteration, L value was 1, 2, 3, 4, 5. Right? After that, we encountered this line. So after encountering this line, we are not returning the value. Before returning, we are entering into a recursive part. Okay. Recursive part is this one, this thing. And in this recursive part, what we are doing? We are sending 1, 2, 3, 4, this thing by dropping the last value, that is 5. We have dropped this 5. Okay. And we are sending this 1, 2, 3, 4 again to this procedure. Okay. Now the L value is reduced by 1. Earlier it was having 5 elements. So the length of L was 5. Now length of L is 4. Right?
Yes, sir.
So in this way, the length of L gets reduced. Okay. And a point will come when length of L will have only one element. Okay. L will have only one element, that is 1. So the length of L will be less than or equal to 1. Correct? In that case, we'll return this 1. So 1 will be returned firstly. Okay. After this, one, what is happening is we have the previous return values also pending, right? In that case, slowly we return. So after 1, we'll return that 2. Okay.
So
Pardon,
what
sir?
is descent of unit of L returns?
What?
What is the descending of unit of L return?
Descending of init of L is a recursive function. Okay, so it is calling itself only multiple times, and when the recursive function ceases, then it returns to the main problem all the return values. Okay, so when I come to this line, okay, when I come to this line, in this line, the thing is, the return value has been initiated. Okay, so the return has been initiated, but the return is not complete, because before returning, there is one more task, is we need to process this list. So 1 2 3 4 5, it was the data, and then we are sending initial of 1 2 3 4 5, that means 1 2 3 and 4 to this function again. Okay, so that return value is there, but it will happen later on. Okay, so in this way it goes on. So 5,
And 4.
then 4, then 3,
Okay.
then 2, then 1.
Excuse me, sir.
Got it?
Well, in case of 1, it will go to the loop now, sir. Means into the state.
Yes, it will return 1 here. Okay, from here it will return 1, just like I showed you here. It will return 1 here. After that, it will return those pending returns. Okay, those pending returns are 2,
5, 4.
yeah, exactly, in that sequence. So it will return like 5, the last of L, then it will return 4, then it will return 3, it will return 2, and finally it will return 1 from here. Got it?
One doubt, sir.
What is the condition?
Hello.
Tell me.
Sir, after running the code first time, okay.
Huh.
5 is stored as a last of L.
Correct.
Okay. And remaining part is 1 2 3 4.
Correct.
When we are running second time, 4 is to be stored along with 5.
Okay, I'll should I try to explain it in Notepad, or have you understood it?
Yes, sir. Please do in Notepad.
Okay. All right.
Then, sir, where this 4 is stored for the second time?
Yes. I got your point. That's why I asked for Notepad. Can you allow me 2 minutes? I'll write it down in Notepad and get back.
Yes, sir. Sure.
Hello, are you there, sir?
Yes. Tell me what happened.
Why you are
Screen is not visible.
silent?
Like, I'm explaining the code in Notepad. Okay, so I'm writing it down. It requires a little bit of concentration. So give me 2
Okay, Okay, sir.
So I have written the code. Okay. I'm sharing my screen. I don't think it's available in PoP. First, tell me, is my screen visible?
Yes, sir.
Yes, sir.
So here is your list L. Okay, just for your S, I have written it. I have like shortened it. Okay, so I've written 1, 2, 3, 4 up to 4. Here, what's happening is first return last of L plus plus. We are calling that procedure again. Okay, with the initial of L. Here, last of L is what?
4.
Four.
Four, sir.
Yeah, so keep 4 in hand. Don't return it right now. So 4 plus open bracket.
Or as a list.
This thing is processing. Okay. So here again in this procedure, I have sent this initial of L. Initial of L, right? That is 1, 2, 3. I've sent this thing. Again, same line. So keep 3 in hand. Don't return it right now. And send 1 and 2 to the same procedure. Okay, that's the initial of 1, 2, 3. Right? Then again keep 2 in hand. And after this, since the length is less than or equal to 1, we return L, that is return 1. So after we return 1, okay, we return all this stuff. Correct? So here it was the first return, it was the second return, it was the third return, okay, and it was the fourth return. Okay, don't think like that. We return this one. After that, we return this. What we say 2 here. Then after that, we return this 3. Then after that, we return this 4. Then it's basically ascending order only. How the program is working. It's not like that. We have evoked this return function first, but we couldn't return because this return function wasn't complete as this part was to be computed. And while computing this part, we came here, and again in this line we saw we need to compute this thing. So again we came here in this line, again we saw we need to compute this thing. So after that, finally here what we saw is our return is getting completed. It's not again it's not going into again recursive mode. Fine. So we will first return 4, then plus 3. Plus means that's plus plus. Okay, here plus means plus plus. So we return 4, then plus plus 3, then plus plus 2, then plus plus finally 1. So answer we get as 4, 3, 2, 1.
So what are the differences, sir? Can you say how the order goes, sir? Can we have to look at the code?
I didn't get your point.
Sir, do we have to begin with the return statement or the first statement, sir?
क्या बोल रहे हो? Return statement, first statement मतलब? Like, see, as I told you, here this return has been evoked first, right? But we couldn't return the value because this thing wasn't processed. That's why we came here. But that doesn't mean after we are done with this, we will return this blue line first, then we will return this line. No. After we are done with this blue line, this line will be returned first. Why? Because this was evoked first. For this line to be returned, we were supposed to do this line. That's why we came to this line. It's not like we will return 3 first and then we'll return 4. No, we evoke this return first, so we'll return 4 only at first. But we process these lines in between before returning, just for the sake of completion of this thing, just to compute this. Okay, so we return 4 as first, then 3, then 2, and then finally we return 1.
Sir, before returning this.
Yeah.
Sir.
Yeah, I can hear you.
Before returning this list, after every steps where we are storing this as a list. Suppose in first go,
it's not
storing
storing, it's not getting stored as a list. It's like remaining in the computer memory. It's remaining in the computer RAM. Okay. As a subsidiary work that it needs to be processed, but before that I need to process this thing so that I can do this thing. So it's like kind of suppose you are given
it's kind of a rough work which we are doing, because this is not being shown in the computer. The final output will be just given.
Exactly, just like you are given something, a computation by your school teacher. Suppose like if your school teacher had told you 2 plus compute what is 2 plus 2. So that's value is 4. So for computing 2 plus 2, you need to first learn what is addition, how addition works, right? So for doing this thing, what do? You buy a fundamental mathematics book, you find out the addition topic, you study through it, you understand the addition topic, then you solve the problem. Okay, but that doesn't mean you were told to study the addition topic. You were just told to compute what is 2 plus 2. For that you had to do that work. It's kind of a rough work that the guy whoever said that's the perfect term.
While going through the code, sir, in the second line, for the first time, it is visible that last of L is stored as a list, and after that plus descend, this process is continued. But after that, only returning list, that is quite confused. Okay, sir.
Is this clear? Is this clear? Any
Yes,
doubt?
sir.
Yes, sir.
Yes.
Clear.
Sir,
Clear, sir.
hello, sir.
बताओ.
After the return value 1, we can start through the iterating through the 2, then 3, then 4.
After the return value is 1, okay. 1 minute.
Hmm.
1 minute, please.
Yes, sir. Understood.
So here, as I told you, it's kind of a rough work you are doing. Okay. So here, after returning 1, after this, we got a fixed value. We are not entering into any more recursive iteration. Okay. What we do, we come back to the previous return value because it was
Yes, sir.
invoked before this return value, right? So we come back here and we check. So after coming back here, we see that it was also invoked some by previous return value here. After coming here, we also see that it was also even invoked by some previous return value. So finally, when we come here, we see that it was the initial return value. That's the very first return value. So we first process this. So here 4 plus of this. So this thing we already know the value, that is 3. After that we again come here, that's 2, and then finally we return 1. That's why 4 3 2 1.
Sir, in like the second subdivision, after 3 plus plus, the 1 2 is returned based on the previous condition, right?
1 2 is the initial of 1 2 3, this thing. Like this is 1 2 3 4, right? I have written 1 2 3 here. That's the initial of 1 2 3 4, and then in the second step 1 2 is the initial of 1 2 3, and then in the third step
एनालिसिस सब कुछ आपको मिलेगा। चैप्टर वाइज टॉपिक वाइज क्वेश्चंस को अलग से निकाल के रखा है, आप इसकी विड्थ देख सकते हैं, क्योंकि इसमें 5 साल की 19 20 21 22 और 5 साल की हमने पीवाईक्यूज डाले, समझ में आया ना? जब आप इसको बोलोगे तो ऐसे आपको इधर एनालिसिस देखने को मिलेगा कि कौन से चैप्टर से कितने क्वेश्चन किस साल में पूछे गए हैं और किस तरफ है आपका इंडेक्स। और जब आप आगे बढ़ोगे तो आपको 2 साल बाद हम लोग ने नीम ड्रॉपर का एक बैच लॉन्च किया। प्रतीक को कहते हैं इस बैच का नाम क्या रखोगे? मैंने कहा इसका नाम यकीन रखूंगा, मेरे प्रतीक के बहुत क्लोज है, मेरा पहला ऑनलाइन का प्रोजेक्ट है। वो बैच अपने आप में एक मतलब एक नाम है, एक ब्रांड है यार। यकीन यूट्यूब पे आप लिखते हो तो अपने आप
Ripushudan, please mute your mouse. Hello. Yes, sir. You can proceed.
Hold on, please.
Sir, are you sharing your slide?
Not now. So should we proceed with the next one?
So can you explain?
Yes, sir.
option, which is correct. The third option.
Third option. Okay. Share screen. Third option. Where? Which one?
In a return descending of rest of L plus plus that.
This thing? Or third
No,
option from the problem?
Third option is the right one.
Okay, okay. From the problem. Okay. All right. What's the third option? Okay. Return descending rest of L plus plus first of L. Okay.
So your screen is not visible.
I know. I haven't shared it yet. So here what we are doing, we are concatenating that recursive part in the first. But
Sir, your screen is not visible.
yeah, my screen is not. Is it visible right now?
Yes, sir.
So here what we are doing, here what we are doing, return descending of rest of L plus plus first of L. So we are concatenating here descending of rest of L. This is the recursive part, right? So we are concatenating the recursive part at the front. Okay. So since we are concatenating the recursive part at the front, so we are dealing with the rest part of it. And when we are concatenating it from the right, that is in the option A, we were dealing of the initial of the L. Can you see? And since we are concatenating here from the left, that's why we are dealing with the rest of it. That's it. It's just turning the matrix. Nothing different.
Yes.
So, sir, move forward to next question, sir. This question is taking so much time, sir.
So can you proceed?
Sir, are you there, sir?
So can you please?
Hello, sir. I am audible, sir.
Is my screen visible?
Yes, sir.
Okay,
It's
we have
visible.
5 minutes time.
Yes, sir.
So exact at 6:50.
So do we have to write the pseudo code or something?
Can you please repeat it?
Sir,
Some summary about
Sir.
what you learned.
So have you done this? Am I audible?
yes, sir.
Should I start the explanation? So here write a procedure that accepts the list of moves and returns true if the bot is at the same place where it started and false otherwise. Okay. So if it started at the same started and ended at the same place, then it's gonna return true. Otherwise, it's gonna return false. Right? So here is this procedure. Procedure each stat moves. Moves are what? Moves are this thing. left, right, left, left, right. Okay, these are the moves. It's a list of moves. So we are sending that list into this procedure is stat. After that, if numeric moves equals to 0, we return true. Okay, else we return false. So numeric moves, it's another procedure, and that's the main recursive procedure. So if this recursive procedure is going to return 0, we will return true. And if this recursive procedure is not going to return 0, if it's returning any other value other than 0, then we'll enter into this else part and we'll return false. So what's this recursive procedure is doing? Let's compute. This is the recursive procedure. Numeric procedure, procedure numeric L. Okay. So here L is that same moves. Okay. Here numeric moves. This moves is the parameter. So here L is that moves only. So we are counting if the length of that list is equal to 0 or not. If it's 0, then we'll return 0. And if it's not, then we check if first of L is left or not. Okay. If it's not left, then we enter into this else part and we return numeric rest of L plus 1. Okay. Rest of L means leaving the first element will return from the second till the and if it's left, what we are returning? We are returning
Right, left, right, left, left, something like that.
hold on. Yes. So if the first of L is left, in that case, we are returning numeric left minus 1. Okay. And if the first of L is not left, and if it's right, then we are returning plus 1.
So can you just go to the previous slide?
So here, if the first of L is left, we are basically like subtracting 1. And else means basically if the first of L is right, in that case, we are adding 1. So here the thing is, once we are subtracting, once we are adding. So if we get like in this way, while recursive, while going on, if the final value is 0, that means the left moves is equal to the right moves. That means at the end, we are finally at that starting point only. That's why it says numeric moves equals to 0, we return true. Okay, so basically our target is we need to check if left moves is equal to the right moves. Left moves are minus ones. Okay, how many minus 1 are there? That's equal to the left move. How many plus 1 are there? That's equal to the right moves. And if left move and equal to right move, that means we are at the same point, at the same starting point. That means
Your
all the
voice is
minus
very
1,
low, sir.
all the minus 1 will be equal to the all the plus ones. So it will cancel out and the final value will be 0 in that case.
Sir, after returning,
Yes.
where we are calculating if numeric moves is
It's like in
The
the
final
computer
value of
mode.
0 is a numeric value, right? It could be
Yes,
anything.
yes,
It's returning-
going to be a numeric value. Just remember one thing here. The thing is, first of L is left. So when we are getting
It
a
is-
left, okay,
It is returning a minus.
that's
One.
returning a minus. And whenever we are returning right, that's returning +1. So since +1 is returning, since right is returning +1, that is taken for
Okay.
granted. For left, we are gonna return -1.
Okay.
Okay.
And then where it is compared for ensuring that whether the robot
Here,
is sound.
here it's finally checked if the final value is 0 or not. Final value of this procedure. Okay. After all this +1 and -1, if the final value is 0, then we should return true. That means we are at the same position. That's the starting and ending point is the same. So let's see their explanation.
Can you please go to 2 of the previous slides? Sir, if it's
1 minute. Can you see this? Left, right, right, left. That's -1 +1 +1 -1. That's equals to 0 only. Did you get it?
Yes, sir.
Yes.
Sum is 0. That's our main target. Now tell me, have you understood this?
Yes, sir.
Should we move on to the next problem?
Yes, sir.
Sir, can you just show this from the beginning, sir?
There you go.
No, sir, even more previous. Yes, sir.
Got it? Well, this is easy. Problem 3.1. Transverse the graph in a depth first manner. This definition should be clear to you. That's it. And you will be able to solve. Okay, it's not a recursive problem. It's just what defines depth first manner. Okay, depth first search. What is depth first search? Okay, so that is the thing. So you start from the node 0 and you apply this sorting, okay, so this search, and you compute the final answer from these options. There you go. You have 5 minutes in your hand. From 7:10, we will start discussing about this.
Option 1 are correct. Please explain, sir. Explain, sir.
So are you done with this?
Yes, sir.
Okay. The correct answer. Option A, 0, 1, 3, 4, 5, 6, 2. So from starting from 0, we go to 1. Okay. And then we go to 3. After this, we have two options, 5 and 4. So we go to 4. After that, 0 is already covered. So from 4, we return to 0 only. So from here, we back to 3, back to 1, back to 0. So after this 0, we go to 5. So after this 5, we go to 6. So after 6, nothing is there. So we return to 5. From 5 also nothing is there. We return to 0. From 0, we see one more is there. That is 2. So we go to 2 finally. That's why 0, 1, 3, 4, 5, 6. That's the answer.
Sir, what does it mean by choose the node to the smaller labels?
Smaller levels means that's ascending order. So 0 has 1, 4, and 2 connected nodes, right?
Okay.
So we need to go ascending order. So we need to choose like 0 to 1 only.
Yes, sir.
Clear, sir.
Sir,
Uh,
0 to 1, then 1 to 3, 3 to 4. Then we are back to 3. Can't we go from 3 to 5, then 5 to 6,
no, no,
then
no,
come back to 5?
no, no, no. From 3, we need to go back to 1.
Okay, okay, sir.
Sorry. Yes, yes, yes. From 3, we are going to 5 only. Correct. And from 5, we are going to 6. Yes. Sorry. I didn't see that. So from 0 to 1, 1 to 3, 3 to 4, then 4 back to 3. Okay, from then 3 to 5, then 5 to 6. Then from 6 to back to 5, then back to 3, then back to 1, then back to 0. After
Then
that,
2.
we go to 0
Yeah.
to 2. Yeah, correct. Thanks for correcting me.
Yeah, right.
Sir, why not from 5 to 0, then 2?
Because 0 is already covered, no? That's why we come to 5. This out there. Whosoever this is zero. Then 3, then 4, again 3, then 5, then 6, then 5, then 2. Got it?
Sir, so after going from 0 to 1, 1 to 3, 3 to 4, 4 to 3, and 3 to 5, and 5 to 6.
Correct. So this is the next question. Are we done? Are we done with this?
Yes, sir.
Yes, sir, complete.
Is this same thing or something different? Okay, it was the same thing.
Same thing, sir, but they're just asking a tree.
So it was asking to make the tree from this graph.
Okay. Whatever. So this is the final tree.
Just a second, sir. Allow me to check.
Now this is problem 4. Go through this. What is the recursive procedure to traverse this graph in a depth-first manner? Starting from any given node I, okay, compute the DFST corresponding to this transverse. This is the procedure, okay. Are you done with this? Can you hear me?
So we can
Yes, sir.
Okay. So here PS equal to DFS APJJ, APSJ. Sorry, this is the answer. Okay. How come this is the answer? So here is the procedure. So what's happening is A is a matrix. Okay. P is the dictionary. So P is empty dictionary. That's written in the first line. After that, A is a matrix that's not empty. Matrix has all these nodes. After this, what is S? S is a list. Okay, that's an empty list. And I is like I and J are nodes. Okay. So in this procedure, we have sent that I node. Okay. And remember that I node is already created as a key in this key dictionary, and the value is -1 over there. That's in the second line. So in this procedure, what happens is S equal to S plus plus I. So this is an empty list. In this empty list, we are concatenating this I. That's the first node. After concatenating this, we are initiating a for loop. We are going through the columns in the matrix A. The columns are these nodes on. So we're going through all the nodes. So Aij, okay, equal to 1. So when Aij equal to 1, we are checking. So Aij will be equal to 1 only if there is a node, if the node exists. Okay. So 0 to 1. Okay, when I is 0 and j is 1, the relation exists. So in that case, Aij will be 1. So that's we are checking. And not is key P J. Okay, so in the P dictionary, if J is not the key, that's 1 is not the key in the P dictionary, then if this both these conditions are matching, what we are doing, Pj equal to I. Okay, so P of 1 equal to I, that is P of 1 equal to 0. Then PS equal to DFS APSJ. Again, we are like initiating the recursive function. So now A is like this entire matrix. A is same as the previous one. P is updated. P was previously empty. Now P has like this I and J. Okay, I over here it was initialized, and J over here. Okay, so and S, what is S? S is also a new S. Okay, S was previously empty. Now S is like having one element, that is the 0. After that J is 1. So now this I is the J. Here we are again entering into this procedure DFS APSJ, this line where my cursor is. Okay, this line. Why we are entering here again? Because it's a recursive function. In this recursive function, we are entering here again. After entering here, A is same as previous one. P has only one entity, that is P of J, that is P of 1 equals to 0. Okay, that is P of 1 equals to I. And S has also one entity, that is S has only one entity, that is 0. And I is what? I is that J of previous
Yes,
iteration. So I is 1. Okay. After this, S equal to S plus plus I. So here S initially had 0. Now S have this I also. Here I is what? Here I is 1. So S will have 0 comma 1. Okay. And then for each J in columns A, we are going through all the nodes again, all these nodes. Okay. And we are comparing if A 1 comma something is equal to 1 or not. So 1 comma 3. So if I is 1, J is 3, in that case it will be 1, and 3 is not a key in P dictionary. So in that case we create P of 3 equal to I, that is P of 3 equal to 1. Okay, and then again we are returning back. So this process continues, and in this way we get 0. We already got 0 and 1, and then we also get 3. After that we get 4. After that we get 5. In this way it goes on. Okay.
So J each time has to be and this should not be a key of the dictionary P, right?
Correct. It shouldn't be the key. Because had it been a key in this dictionary, that means we have already encountered that node, okay? And that shouldn't have happened.
Yes.
That's why that
So can you show the full form of APSI?
full form of
APSI. What are they called?
it's not a full form.
The
These are
matrix,
variables. These
A
are
matrix.
parameters. A is the matrix, B is the dictionary, S is the list, I is that entity. That entity
Okay,
has
okay.
the iteration.
Sir,
Thank
why
you.
we are initializing -1? Actually, if there is no incoming nodes, normally it is 0, no?
But they have initialized -1. Actually, it's not hard and fast rule that we should initialize it with 0 only. Depends on you.
Okay.
So why it is initialized -1?
As I told, there is no hard and fast rule. They have just initialized it with -1. Okay, that's the thing.
Okay, so we can initialize 0 as well, right?
Depends.
Okay.
Sir,
I think this
Hello.
slide is done.
hello.
Yeah, hello.
Sir, could you please explain this after and part? Not is key PJ. I could not get that.
Like where?
Second part. Yes, sir.
The whole procedure.
And not is key PJ. That I'm not able
Not
to
is key.
visualize.
Not is key P comma J. That means in this dictionary that key shouldn't that J
Initially,
should be of
P
various.
is empty.
Okay, so that's basically
Initially,
like
sir, initially P is 0, 0 matrix, empty.
P is not a matrix. P is a
That is
dictionary.
empty.
That's the empty dictionary.
J is the key, no, sir?
J is the key, correct. So we are checking, we are picking a new node, okay? So that node is termed as J, okay? So every time this node will change with every iteration. It will be 1, then 3, it will be 4, then 5. In this way, it will go on, okay? So J value will be the node, every new node, okay? So is key, not is key P comma J, that means we are checking if that J is not a key in that dictionary P. That means we are checking if we haven't gone through this node earlier before, and it's the very first time we are encountering this node. To make sure this thing, we have written this condition not is key P comma J. So if J is not a key in this dictionary P, that means we haven't encountered this node earlier before, and we are safe to go with this. Is this clear? Just one more
Sir,
problem.
it is
Should we move on to the next one? Have you all understood?
Yes, sir. Yes, sir.
Okay. So this is our last question for today. So is this even a last question, or we are already done with this, I guess?
Is this weighted graph, sir?
Okay, it's just like the explanation. It's just the further explanation only.
Okay.
Okay, you can check it. Like slowly, you can check it. How is this computed? So these 2, 0, 1, 3 that's written on the left hand side, these are the keys of the dictionary P, okay, here. And the values over there, that's -1, 2, 0, 1, 3, 5, 3, 5. These are the J values, okay. This -1 was written initially in the very first or second line.
Okay, sir.
So you see that was -1 was initially, then after that 0.
That means, sir, 2 to 0, the edge is 2. What is that meaning?
0 to like
The number of times it's visited.
No, sir, the
Oh.
weighted, the weightage, the edge weightage is like that.
no, the thing is like, what is this? As I remember, there is something P of J as the key. That means 0 as the key will store I. I is what? I is the previous J, right?
Okay. Okay.
I hope you remember that from here.
Yeah. Yeah.
I is that previous J.
Yeah. Yes.
Correct? So is this clear?
So what is the question?
It's not a question. It's like the previous problem continuation.
It's like the path, no, sir. -1, and then a previous of 0 is 2. Then one of previous of 1 is 0.
Correct.
And 3 is 1, like that. No.
So how come the I becomes initially 2?
How the I becomes initially 2.
Yeah, in the starting of the dictionary, 2 is initially the key is 2, right? And the value of that is -1. How
Yeah.
come that is initialized as 2?
Oh, an initial vertex. That is 2 is the initial vertex from where the graph is starting.
Yeah, P of I equal to -1. Here it's written in the second line. So I is the initial vertex. Okay.
But then we are starting from 0, right?
No, I hope you haven't read.
No, this is a different graph, directed graph. This is the directed graph. The direction is shown here, mentioned here. No, come to down, sir.
See, hold on. From any given node, can you see? Any given node I.
Okay.
The given
I
one I
understand.
is 2.
Nice.
Got it?
Yes.
So it's a very good thing that we finish this entire solve with us PDF. Okay. And the great thing is we have finished it on time, because it's the very second lecture I'm taking regarding solve with us. Is basically the instructor session, but the instructor is not here. That's why I'm taking. So I hope I was able to clarify all your doubts.
Well, can you just explain the last question?
Last question in what sense?
The 4.2.
4.2 is not a question actually. It's like the explanation of the previous one. It's just a continuation. That's it. It's like
Your voice is very low, sir.
it's not a new question. It's like it's have written that
the value of the key and the
value of the keys and the value that value of the j as the key and the I. Okay, that's means it's just projecting the dictionary P. What's happening? Nothing else. It's not a new question. 4.2.
So then can you just show the last slide?
Oh, sorry. Visible?
Yes, yes. You just scroll further down.
Nothing is good. This is the very last page. Okay, Dania?
Yes, sir.
All right. So we are closing the session right here as we are done with this Solve with Us PDF. Okay.
Okay, sir. Thank you.
Thank you, sir.
Thank you,
Wish you
sir.
a very good evening,
Thank
everyone. And there is one more session from 8. So if you want, you can join that. Rishita will be conducting that session.
Okay, sir.
Wish you a very good evening. Ahead.